So, hi, I'm Chris, work for the National Library of Iceland. I'm also the co-chair of the Harvesting Working Group, have been for a long time. Roger neglected to mention, he's recently joined me as co-chair as well. So, if you want to participate in the working group, you can contact us and if you have any specifics. So I'm going to talk about everything except DecideRules, but I'm also going to talk about DecideRules. So, probably most of you, at least those who are not just still stuck in Heritrix 1, have seen the CXML files. This is Spring configuration. Learning Spring helps a lot. So if you haven't, it's really worthwhile just understanding how this syntax works. I'm not going to go into that, but it is really worthwhile. It makes it so much easier to infer what else you can do. And you can do a lot. It's a really powerful tool. So at the top, there's this block that allows you to do overrides. And what is very useful about this override, property override configurator as it's called, is that it lets you take all of the things that you tinker with every time you launch a crawl and put it in one place. So you don't have to go hunting through all of the XML. And most people don't seem to bother with this. And in fact, it took me a long time to just realize that this is much easier in the long run. Part of the problem, I think, is that sometimes figuring out exactly how to express this, let's say the strings here is perhaps not entirely clear. And I'm going to take an example of this one here, the seed, to show you how that is done. I also want to point out that the crawl metadata, this gets written into every work file you create. So taking the time to set these values correctly from a preservation standpoint makes a lot of sense. So don't neglect them, even though they don't directly affect your crawl. It does affect the output and is not to be ignored. So now, people in background, can you read this font size? Just all right, I'm going to take that as a yes. So this is probably familiar. This is specifying the seeds in an external file. So as you can see at the top, we've specified this file with seeds.textsource.path, and you can see here that this is referencing this ID, this property, and again this property within that property. And this is the way you can address things in the CXML. In the Spring configuration, it's just this hierarchical system. So if the property is a bean object, then you can then address its properties and go as deep as you need to. It does though make it easier if you need to reference something here to have the bean near or at the base layer that is specified at this level, because it just makes it a lot easier. You don't have to do like ... Yeah. And it also helps you if you're doing the command console, the programming console, scripting console, I guess it's called. You don't have to, then again, do these sort of deep invocations. We can just reference it. So I want to bring your attention also to this little thing, config file. So there are a number of places in Heritrix where this convention is used. You have some sort of source. This is actually what Heritrix calls a read source under the hood. And it can accept either a config file or it can accept a config string. And those are fairly obvious. What isn't really obvious is that these are pluggable modules. And you could, in fact, put in your own little source, your own implementation, and instead of reading from a file, you could read from an HTTP source, or from an FTP source, or from Git, or from wherever you want to do. Heritrix doesn't provide these, but if you have a reason, if it would help your flow to read the seeds, not from a file, but from an HTTP source, and this is actually something I'm considering for us, then you can just swap out the config file for your own implementation, and just as long as it implements the read source interface, which is actually quite simple. I'm going to just pull it up here real quick. And so most of these are just simple. Oh, sorry, this is resource editor. Apologies. So it's in the web archive. So it's in the comments. But as you can see, the implementation of this is fairly simple. It's just about providing the reader, and that's really it. As long as it provides a reader, and how you do that is just an implementation detail. Heritrix doesn't care. You implement whatever to talk to whatever system you want. And we'll talk more about this later today. So we have I have my scope. By the way, this is our actual domain crawl configuration with a few. I removed a few things just because they'd be a distraction. So I'm going to skip over the scope for the most part. But as you'll notice, I declare a lot of the beans outside of the DecideRules. So, and I do this purely so that I can have easy access to them via the scripting console referencing. And so they have their ID, making it easy. And this is just one of those things that you learn that if you don't do this, you find yourself spending a lot of time trying to figure out how do I access that bean. Because at runtime, you sometimes need to tinker. All right. So aside from the scope, Heritrix is basically about two things. One is the frontier, which I'm going to get to, and the other things are what we call these chains. There are 3 chains, and for each chain you get you cram the URIs through them, and stuff happens. So the candidate chain is what you cram through discovered URIs, and by default, it's 2 classes: the candidate scoper, which really just pulls up the scope, applies all the DecideRules, and then tosses it out if it doesn't match. And then there's the frontier preparer, which should now only be applied if it's past the scope, right? And it decides which queue it's going to go into, and a few other things like that, including if it is to be penalized as an expensive role, and if it should get put at the front of the queue, and a bunch of things like that. And confusingly enough, it also holds a reference to the scope, because I don't know. It's one of there are a few stupid things like this in Heritrix, and if you look at this, there are a few omissions from this chain, right? I mean, you could do so the frontier itself will discard URIs that is already seen. Why that isn't in this chain is a mystery to me, and a few other things. So, but this is the place. So if you want to do something before things get scheduled, just as they're discovered, some sort of an analytic or whatever, this is the place to put it. Now, fetch chain is obviously the big one. This is the one that actually gets our content. Most of these are standard. You don't mess with them a whole lot. Starting with the pre-selector, which can reinforce the scope. So this is the 3rd place we wire in the scope. Usually you won't actually see blocks like this. It's just auto-wired, but I prefer the explicit nature of it. So makes it a little clearer. And you can also use this. I'm going to point out you can use these fields here, especially the allow and block all by regex. These aren't useful as a general setting, but as an override setting, you discover that you need to block things out for a specific domain or something. It can be useful. Although you can also do this by just having a scope rule and rechecking the scope. Nice thing about this, this is most useful if you don't recheck the scope, because discover and you want to filter them out. Most people recheck the scope. It's not that expensive. Running all of those DecideRules and whatnot, even if you have, like me, we have a ton of DecideRules, it's still not really all that expensive. So the precondition enforcer is just about the robots and the DNS, and there's a really nifty one there if you are a national library and can ignore robots, which is calculate robots only. So we just configure it on a robots, and then we flip this toggle, and all the robot text rules do is add an annotation in the crawl log saying this should have been ignored because it violates robots, but our legal deposit law is allowing us to do this, and people don't seem to complain. So yeah, but if you want to ignore robots, this is the way I recommend you ignore it, because then you have a record of what you actually ignored. Otherwise, you'd have to reconstruct it from the files, which is a lot more work. Then the fetch DNS, which and the fetch HTTP, I'm not going to mention them much. They run pretty much standard. And yeah. I'm going to talk a lot more about the deduplicator after lunch. I'm going to dig right into it, but I just want to point out, as Roger was talking about, you can use the DecideRules sequence here to control what gets deduplicated to some extent. So you're not wasting time on HTML documents. HTML documents don't deduplicate well. This is followed by the extractor. So there are a lot of extractors, and they do different things. The HTTP extractor is mostly involved in things that are indicative of HTTP, and finding if it's a 300, it will extract the redirect, for instance, and things like that. So you want it. The trap suppress extractor is really, it's a trick, a trap in itself, because it will notice certain types of URIs and decide this doesn't look like something we should be extracting anything from. It'll just flag it as having been link extracted, so the other ones will skip it. So it's kind of a little trick. Whether it's useful or not, it's debatable. It doesn't really, I haven't done the math, but it doesn't seem to eliminate all that much, but it's not harmful. The HTML extractor, you will notice, is not the standard one. You can tell from the package name, IS. So this is a fork that I created simply because there were problems with the JS extractor. And the HTML extractor uses the JavaScript extractor. So those two are linked. It's very difficult not to change both of them at the same time. And as you can see, I've also got the special JavaScript extractor. I may need to back off on this because they've improved it a lot, but there was a problem in like 3.1 where it was just way too aggressive, and you'd have a lot of false positives. And I mean a lot. It was horrible. So what I did was I basically went back to the Heritrix 1 level of JavaScript link extraction. And because it was easy to do so, I added this thing called reject relative matching regex. And it's basically if the JavaScript extractor finds a relative link, so it doesn't start with HTTP, all of that, just a relative, it will match it to these regexes. And if it matches one of these, it will just toss it as being likely garbage. And you can see stuff like text/JavaScript, which is very common to find. It's not a path. It's there are, as we saw here, this is incredibly common to have 3 or 4 numbers with dots between them, and these are usually version numbers or something like that. They do not represent. So I may be losing a little bit of content by doing this, but I'm getting rid of tens of millions usually of complete garbage paths. And you notice this is only for stuff being extracted from JavaScript. Those same paths, if I extract them from a ref link in an HTML page, I'll definitely crawl that. That's why it's there and not in the scope, because I just want to ignore it if it's coming out of the JavaScript extractor. And while the scope does let me look at the hop path, which has things which would usually have like an X for JavaScript, the X can also mean other things. It's not just JavaScript. So by putting it there, I can very narrowly target it, but it does mean I have to tinker with the code. And as I'm going to talk about a lot more after lunch, tinkering with the code is absolutely essential to getting Heritrix to do exactly what you want. So the fetch chain runs through all of this and then gets you to the disposition chain, which is responsible for writing into disk mostly. So this is mostly the WorkWriter. The first one is actually my load disk pause. There is now a proper module in Heritrix for doing this that isn't in the fetch chain, but it just runs as a bean on its own, which I prefer. I'd recommend above this one. The only thing this one has is it does. So if you notice there's a processor report, and this one pops up in that, which I find useful. That's the only reason. WorkWriter. Generally, you don't have to mess with it much. The defaults are pretty good unless you have a specific reason not to. If you're doing checkpointing, I do recommend this, just so that you can, like when you're restoring from a checkpoint, anything that got crawled after the checkpoint, you may possibly just want to discard it as being an incomplete thing. You're going to recrawl it. So starting a new file whenever you checkpoint makes sense. But that is yeah. Most of these are just very sensible defaults. The only thing, because you might want to share, the default is IA, so you're going to want to set this. Obviously, you should all be familiar with the disposition processor. So based on what's happened to this URL, this will tell the frontier how to treat the queue with regards to politeness. And these are conservative settings. I think they're still a little bit more aggressive than other defaults. We've had a lot of problems with this. So the robust.txt can now specify minimum crawl delay. And some websites just put this number very, very high, meaning it takes a very, very long time to crawl them. So we sort of, with a little bit of trial and error, wound up with 30 seconds as the maximum. So we won't go higher. So if it's higher, we'll just wait 30 seconds. You'll have to figure this number out for yourselves, but I wouldn't leave this at anything more than 60, maybe 90 seconds. Because otherwise, it takes forever. If you're only crawling one document a minute, that's 60 documents an hour. I mean, it's even a fairly modest website is probably tens of thousands of pages. So now we get down to a few other things, which I'm going to touch on a little. The crawl controller, aside from the max tow threads, you shouldn't have to mess with it much. Figuring out the value of the max tow threads is a little bit of trial and error. 75 is good for medium hardware. Usually you wind up being I/O bound. So if you have it higher, it will you get this burst initially as everything's in memory, and then it will slow down to the same number as if you just started out with a lower number. But usually 50 to 100 is the sweet spot, unless you've got serious hardware, like super fast disks. Then you might be looking at up to 200. If you want to improve your crawler speed, get super fast disks. That's usually where.
What is tow thread?
Oh, okay. So the chains I was talking about, each tow thread is basically running through the in parallel through those chains. So it's how many URIs are being processed in parallel. Okay. So usually they wind up waiting at one of a few places. The fetch HTTP is obviously where they're going to wind up waiting just for network responses, and then things like the WorkWriter where you're waiting for disk. They will tend to blast through things like the scope where everything's just happening in memory. Most of the other things are fairly standard. Don't think worth much of a mention. The frontier.
What's the correlation between max tow threads? How much memory you need to have?
Tow threads do not use much memory.
Okay.
So no. Actually, I'm going to get to the memory hogs tend to be the frontier structures about the queues. And as you can tell, we're now here in the BDB frontier. So what it will tend to do, unless you configure it otherwise, and I don't recommend that, is that it will try and have enough queues in a ready state so that the tow threads are all busy. And queues that aren't in ready state are sort of put into, they're basically shuffled off to disk. But there's always new stuff coming in, so there's a little bit of memory required for each queue. So if you have a crawl that spans hundreds of millions of hosts, each one of those hosts is going to just require just a little bit of memory. And so that's usually going to be where you run out of memory. But it's pretty good about, I think, inactive queues that are, it's only, I don't know, but it's less than a kilobyte. But the active ones, which you're only going to have a few hundred of, will be a lot, and they'll be using the cache a lot. And so this, these values, queue total budget, and especially the balance replenish amount, are what controls how queues get rotated into and out of activity. So when a queue becomes active for the first time, it gets the total budget, and if that's exhausted, it's just retired and won't be called again. But it also has this replenish amount, and that when that gets exhausted, it just gets put into an inactive state, and then gets to come up again once every other queue has had a shot. So this way, it sort of winds up being bursty on a few hosts, and the values you choose depend on how long you want it to spend. So these are obviously not good values for a domain crawl. It's 100 and 100. But what we do, and my next topic, it has to do with, I need to skip down a fair bit. It's to do with the sheet overlays, which is a really big topic and one of the really powerful things in Heritrix 3. If you haven't figured out how sheets work, now's the perfect time, and you should get to grips with it. So sheets work by using these two elements. One of them is the sheet itself, which is here, and you can see it uses this class sheet. And it's fairly familiar to the overrides we did. So you have the frontier, and the balance replenish amount, and then the new value. Right? I mean, this is just like doing that at the top. Yes.
Can you explain a little bit more what do you mean by sheet? What in this
Yes.
context is sheet?
I will. I'm doing it. So a sheet is conceptual. So all the configuration we've had above. If you imagine you take a sheet, transparent sheet, and you put it over it, and then where these keys are, like frontier, balance, replenish amount, you just type in a new value over the other one. So the sheet is basically creating a variation on the configuration from above. And in this case, it overrides the balance replenish amount, it sets it to 3,000, and it overrides the queue total budget and sets it to -1, which means unlimited. Call as much as you like. So any URL that matches the conditions for the sheet is going to have those rules and not the rules we saw above, which is 100 and 100.
So it's like a version control or something?
A bit. So it's creating a variant, and we control which URLs get which variant. And how we control that.
The fragment above is
Yes.
saying Facebook.com, Graph.com, IS, those prefixes have that sheet applied.
Yes.
So you can
Okay.
layer that on top based on
Okay, I
prefixes.
got it.
Yeah.
How many additional sheets can you have?
As many as you like. And I'm going to.
Would that have any impact on performance? Across?
Once you start getting into tens, hundreds of thousands, maybe, you're never going to do that.
Then you wouldn't use sheet, you'd probably go back to the main
Yeah, you probably. So you don't use sheets for different crawls, you just use it for variations within the same crawl.
Is it a must for every crawl that we?
Sorry, could you say that again?
Is it a must? Setting sheet is it a must?
It's not required, but it is an incredibly powerful tool that you have. If you don't want to use it, you can still crawl, but it gives you flexibility that you otherwise don't have.
Which applies to a small group.
Yeah, you can say. So what I've done here is that I've said any domain that starts with IS, within the IS top level domain, plus Facebook and Gravatar, because we need to do that, they get unlimited queues in their crawl. So they crawl with we want it. So this means that if we stumble upon a random .com, and due to some scope leakage, we start crawling it a lot, it gets capped at 100 captures. So we just, we could have done it the other way around, but then I would have had to enumerate all of the other top level domains, which I didn't want to do. So I just set a really limited default and then overrode for .is. And we have then this one, which then undoes that. So all of these many domains have been identified as problem domains for numerous different reasons. And keep going and going. And so they get attached to a sheet called crawl limited, and it basically overwrites it again. So it sets the total budget down to 1,000, and it actually does something else, which is, so usually the queues are just based on the host name. So but this one actually tells it to only use 3 elements of the host name. So if it's if it's a.b.c.is, we cut off the a and just use b, c, because it's the number of host segments. So I think it's probably clear if we use an example from up here somewhere. So this would be a host name with 3 elements. So you got IS, you got Havro, and you got Cran. But if it had another one, this one would usually be part of the host name, but because of that limit, it gets cut off and just ignored. I'll talk about this a little bit more after lunch as an example of creating your own.
And they're applied in like a linear order, so you have your...
Yeah, my understanding is that the sheets are applied in the order they appear in the CXML. So their order within the CXML is important. So if it matches multiple ones. And I have here a few more. They tend to operate along similar lines. And as I'm running out of time, I'm just going to skip and show you one last thing. So usually you use things like the cert prefixes sheet association. So you're just doing cert prefixes. But you can also use a decide rule to decide when a sheet should be applied. And this is an example of that. And it just uses the IP address set decide rule. But you could also put in a decide rule sequence and do multiple decide rules in order to decide what gets through. So you can base this on pretty much anything you like.
In the target sheet names properties, why isn't the name referred as a ref bin, but just in this value?
So this is in Spring that ties this and this. This is not Spring that's tying this together. Heritrix understands this bit, and so this is just the way it works. And you can specify multiple sheets here, so you can have one association to multiple sheets if you like. All right. More questions?
Kristinn, do Spring allow for include files?
Yes.
Because you see this,
yes.
This is a very long file.
Yes, you can do the standard Spring import.
Okay.
And in fact, the sheet should probably be handled that way, but I haven't gotten around to it. Anything else?
In real life crawling, how often do you tune these values?
So the values themselves, not much, but some like this long list, every time you do a domain crawl, it gets a few new entries.
So do you do this on an ongoing basis? So if you have the crawl running and you update your sheet, do you pause the crawler?
So updating the sheet is just for the next crawl, right?
Okay.
But via the scripting console, I'll often throw it in there as well, just to, if I've decided. So it's
we tend to try and be very consistent. Anything we do at the scripting console, we immediately try and reflect in the beans so that they're kept in sync. But it's a bit. It would be nice if we just pull the beans out of Heritrix, but you can't because it's too deep. It's too deeply nested. But you have to get a bit of discipline required to keep your recorded configuration consistent with your active configuration.
Yeah. The only thing I'd add to that is that, especially the crawl limited sheet, Often I'll associate domains with it when I just decide that they're now into crawler spam, just nonsense, calendar, whatnot. But I don't want to add it to the crawl limited because it isn't, the depth isn't 1,000, but maybe we want 15,000 from it, and I don't even maybe know the value. But I've decided at this point, we're crawling for 2 weeks, we're definitely into garbage. So I'll associate just to kill it off because it's an easy way to kill that queue off. It's not. There should be a better way of killing a queue, but as you've discovered, there's a bug somewhere.
Yeah,
in it.
I gotta be able to do that.
Yeah. So I've used this method because it's very reliable. All right, I'm over time, so I'm gonna pass off. Thank you.